that is divisible by itself and 1. Meaning that the only two things that could go into a prime number would be 1 and itself. So what's the first prime number? 2. So I want to put a note on that one time. Note, very important. 1 is not a prime number. That's the first thing I will know. 1 is not a prime number. Okay? So 2 is the first. Hey, I don't like this writing. Pardon all you. That's not. I have to pause this recording. Hold on. I need to change this. Right. So 1 is not a prime number. 2 is the first and only even prime number. Okay? Everybody good there? Right. So, which numbers here are prime numbers? They said from this set, they gave you a few numbers. It's not all the numbers, right? So, they want you to write down numbers which are prime. So, from this set above here, remember, set is a group of things bounded by curly brackets and separated by commas. That we talk about, right? So, which numbers here only have 2 factors, itself and 1? 3. Excellent. So, that's the first prime number, 3. So, we write it now. So, we go back to blue. So, 3. Let me go again. What else? 3, 7. Right? So, the only things that could go into 3 would be 1 and 3. Everybody agrees? The only things that could go into 7, the only numbers that could go into 7 will be 1 and 7. 8. We have numbers that could go into 8. 4 could go into 8. 2 could go into 8. So 8 is not a prime number. Everybody good there? Right. 16. Prime number? No. 17. Yes. 17 is a prime number. Anything else? I don't think so. 27. 9 could go into 27. 3 could go into 27. So 27 is not a prime number. I think this is the last one, right? 25, 5 to go into 25, 5 to go into 30. So these are all our prime numbers here. Everybody good there? Right, let me see what else this question asks for. Even numbers is the next thing, right? What's that even number? No, let me write a little definition now. Note. An even number, so you'll try to write the same speed I'm writing so that we don't have to wait, right? So an even number. Yeah, note. So here we're doing these things, right? I sending this to you all in the group, right? So what you could do, don't write down like the full question, but you come in, you put number 1. You're doing it just like I do it. You put your note, then you put part A, you write on your prime numbers. Underneath part A, you put notes, you're writing this down. So an even number is exactly divisible by 2. Okay? Meaning 2 to go into an even number exactly. Right? So, while you're writing that, we could probably look at it by the meanwhile. Right? What are the even numbers above here while you're writing? 8, exactly. Very good. 8 was 16, excellent. 25, 2 could go to 25 though? No, you got to remain there. Right? 30. That's the 3 even numbers. Let's go. Let me work. We come here to play. Play time is over in maths all. Right? So 8, 16, what's the last one? 30. Boom. Talk to me. Tell me for a good day. I don't need to leave it on pause when we talking and thing. Or like we doing work. Oh, sorry, like we do now personal work. Right, let go. Note, what's our odd number? What do you think our odd number is? Not divisible by 2. Right? Meaning that when 2 goes into it, it will have a remainder. So we'll put that. An odd number is not divisible by 2. Is not, check, is not divisible by 2. Right? So meaning when 2 goes into it, I should put the word exactly. It's not exactly because it is divisible, but it's just you'll get a remainder. So let's put this word exactly here for me, please. Exactly. So it is not exactly divisible by 2. Okay? So when are we ready? Let me check the odd numbers above here. Scrolling up, right? Talk to me. Odd numbers. Now, 1 is an odd number, by the way. 1 is an odd number. So we started 1. 1, 3. The dog doesn't say 3. Was 7, 17, 16. 2 could go into 16 exactly. 2 into 16 is 8, right? 17, 25, 27. 2 can't go into 27. 2 could go into 26. Right? So those are your odd numbers. So 1, 3, 7, 17, 25, 27. Now remember that. 1, 3, 7, 17, 25, and 27. Boom. Those are my odd numbers from the set above, right? Right. So we're going to write the definition for a multiple, right? Multiple. So let's go. We write in. A multiple of a number is the result you get when you wait is the I'll leave out the word result. I'll leave out a full word yes, right? So a multiple is the result. So that's shifting this and I'm putting result in here, right? Is the result you get when you multiply the given number by another whole number. By another whole number. Right? So multiples are kind of going up. Right? So if I have 6 and I want the multiples of 6, but I want the multiples of 6 from above. So I just want to explain something before we write on the multiples. If I have 6 and I ask you for the multiples of 6, is the numbers derived when you multiply 6 by another number. So look at them. If you multiply 6 by 1, what you'll get? 6 by 1 is 6. 6 by 2 is 6 by 3 is 18 and so forth. Excellent. Let me come up proud. Right? So these are multiples going up, right? So it's like a number. It's like in layman's terms, it's a number 6 can, you'll write on this, divide. Anything I write, we write, When you write, you internalize. It sticks. Please get a reading pen for me by tomorrow. right? Because when you see a half bread in your book, it pops. So when you do your revision, you will know that, wait, boy, this is something serious. Must say right here, boy. Let me see what's going on here, right? So it's a number 6 can divide exactly into, right? So we're going to look for numbers that 6 can divide exactly into above. So I'm pausing by the meanwhile. Yeah, it's 18. I don't think it's 18. So we go back down. We go back down. So tell them, right? Watch it. And just to tell them, it have any other number 6 go into here? No. So tell alone. Right? So alone. So let me go. Your answer for this, and let's put it here, dot, dot, let me put it in blue. Dot, dot, 30. That's all. I'm going too fast, anybody? Right. Factors. Right? Right. So a factor of a number is a whole number that divides exactly into another number. All right, I'm coming down here, right, guys? I'm coming down here, but I'm coming under the computation heading, right? So divides exactly into another number without leaving a remainder. Boom. Right? So if we talk about the number 27, right? That's the number we basically talk about here. 27. Right? Factors are numbers that can divide exactly into 27 and not leave a remainder. So your first factor will always be 1. And 1 to go to 27. Right? Give my next number. No. The last one is 27. 3. Excellent. Right? 12. 9. And what? 27. That's the last one. Right? So a little note I want to put here before I give you the answer, right? Write on this note. Every number has a finite amount of factors, right? A finite amount of factors, meaning that the factors can be counted. How many factors we have here? How many factors of 27 we have here? 4, right? You can count factors, right? But you cannot count multiples, right? So multiples are infinite. So let's write that. Multiples, let's give us space. All right, that's all. I'll go back to it. Look. Let's write this. Multiples I are infinite. You can count multiples. You're going, if I get the 6 numbers, you go 6, 12, 18, 24, 30. You will never finish counting multiples. They are infinite, right? Cannot be counted. right? So we pause it there. I want to give my dog a little chance to right to come back now. Let me just see what are the factors of 27. What are the factors of 27 above here? Talk to me. 1 and 3 and boom. 1, 3, 27. Write it down. Write it down. You're writing it right here. You go ahead, Demon. Right. So 1, comma 2, comma 27. That is no 3. Smoking, man. Smoking. We put it as simple as this, right? Layman terms. Right. Don't even stick. Right. Notes. You go ahead. You write them up there. Composite numbers have more than 2 factors, right? Something else I have to remember. Prime numbers have 2 factors. Prime numbers have 2 factors itself and 1. Composite numbers have more than 2 factors, right? So what I call mark down the man, that's all. Right. Give me the composite numbers here. 8, 16, 25, 27, and 30. Right? Remember them numbers, 8, 16, 25, 27, 30. So you're going to write it. So you write it in blue. 8, 16, 25, and 30. Right? Right. So we write a note on LCM by the meanwhile. Right. Lowest common multiple, right? Also known as LCM, right? Right, let me look. So the LCM of 2 or more, come right, bro. That yeah, what you doing, bro? Leave a space and try to keep up from here. So start from lowest common multiple and start to keep up. So let me go. Lowest common multiple LCM. So the LCM of 2 or more numbers is the smallest multiple that is common to all numbers given. Right? So basically looking for the smallest multiple that is common to all numbers given, right? Pause it. Notes. to find, come on, right, bro. I never move nothing. Look, all the same things here. Where's writing? There we go. Don't get frustrated. Keep fighting now. Don't give up by dog, boy. Anyway, again, it's in group. I said it's in group for you. Who have a phone? You have a phone, right, mother? All right, let me go. Notes. Right, notes. To calculate the LCM, we start dividing by the smallest prime number. Right? We start dividing by the smallest prime number. And I bring some outside like AC word. Okay, the smallest prime. So using the same process that you use in primary school. You'll probably, some of you will probably remember this from primary school. So watch it. You're lining up the numbers like this. Boom, bang. You're putting 4, 5, 8. Right? We're trying to find the LCM. So you start with the smallest prime number. What's the smallest prime number? The lowest prime number? 2. Boom. So could 2 go to anybody here? Any of these 3 numbers? Both 4 on it. So you're going 2. 2 into 4 is 2. Could 2 go into 5? No. So you bring down the 5. Right? 2 into 8 is 4. Right? Then we use it 2 again because it still have stuff 2 could go into. 2 into 2 is 2 cannot go into 5, bring it down. 2 into 4 is boom. Then could 2 go into anybody else here still? Yeah, it's a TRL thing 2 could go into, right? So we're going 2. Let's put this here. I'll find this line or else think by. Hold on. I want to draw back this one. Boom, bang. Right. So 1, 5, and 1. Everybody good there? So what's the last thing here we need to divide? 5. You go to the next prime number that can divide into any of these numbers here. So you get 1, 1, 1. This is the mission. You get 1 underneath here, right? So therefore, dot, 1, 2, 3. This means therefore. Anytime you want to put the word therefore, you just put dot. Therefore, LCM, you're multiplying all these bad boys here coming down. Right? So it's going to be 2 multiplied by 2 multiplied by 2 multiplied by 5. That's my LCM. So if you can multiply this fast using the calculator, right? You say 2 by 2 by 2 by 5, you get your answer. You can't use your calculator for anything moving forward. Eh? So 2 2s are 4, 4 2s are 8, 8 5s are 40. That's my LCM. Write it down, my children. Right. HCF. Highest common factor. Boom, bam. Let's go. Highest common. Bro, that's how it has been on my classes, huh? Highest common factor. HCF. Everybody good there? Right. Let me work. Comment to work though. Here, I just tell my students, brothers, if you can't do this little stupid mathematics, right? For 2 years span and pass it. How are you going to be ready for the workforce? How are you going to be ready for life, boy? To mind children and things, boy. If all you can handle this little dotations. So that's why we are solely up handle this so that the future family will have it good. Right? And everybody gonna be stellar fathers out there. That's what we're raising. Raising the bar. So let me go. I'm sorry, not A, the, wrong word. The HCF of two or more numbers is the largest number that divides exactly into all of them without a what? Remainder. Boom. Without a remainder. So what you can do, because the factors, well, the numbers are small, you can simply just list out the factors, right? So let's list some factors here. 4. What are the factors of 4? Belt them. 1 is always a factor. Everybody agrees? 1. 1 what? 2. 4. Talk done. 8. Hitman. 1, 2, 4, and 8. Everybody good there? Right? Let me work. 12. Hitman. 1, 2, 4. Hey, we missed out 3 out. Let's put there 3, 4, what? 6 and everybody good there? Factors. All these numbers can go into 12 without a remainder. Right? Last thing here, 20. Let me work. 1, 2, 3. 3 could go to 20. 4, 5, 10, and 20. That's it. Right? Everybody good there? So what looking like the highest common factor here? What kind of food thing this is? Which is the highest common factor there? Common meaning it appearing all. Which is the highest common factor? Watch it. Which is the largest number that is common in all the factors are listed? 4. Don't food it as scholar. 4. Watch it. Common. I don't know what the word common means, right? It means it appearing in all. Right? So watch it. You all seen it here? Boom. Is there anything higher and common? Now you realize 2 is common. Did you all see 2 is common? But 2 is not the highest dog. It had something higher. Right? So therefore, therefore, my HCF would be equal to 4. Talk done. Talk is done. Right. So we're going to deal with worded questions involving HCF and LCM. So I want to give all a note on this before. So worded questions involving HCF and LCM, right? So this might be all we might get done because we only have like about 7 minutes of class again. Class flyer. Yeah. Right. So to identify what to use, okay? To identify whether to use HCF or LCM, we look for keywords, right? So, right. So, hey, this man done make it out there anyway. So, keywords are what we're looking for. Keywords will assist in identifying whether to use LCM or HCF. All right. Right. So keywords, right? So let me deal with LCM first. So LCM, your keywords would be lowest, right? What else? Least. What do you think is our next one? Minimum. Smallest. Right? Right. So also have some phrases, right? Etc. Okay. So we also have some phrases. So these are keywords, right? Put keywords here. Keywords. Right? So let me do HCF one time. HCF would obviously be the opposite, right? So HCF will be highest, most excellent, highest, most, yeah, maximum, most largest excellent, maximum, largest. I'll just put ETC. Or look at the idea, etc. Right? Then we also have phrases. Right? That's all going back up. Right. Phrases. Phrases. Right. So when you see things like, so for LCM, when you see things like when they say the first time they will occur together, right? When they say after how many, anything, after how many, after how many, after how many something, right, will they meet again. When you see that, you know it's LCM, right? Okay, for HCF, we done. We just had 2 minutes. Bell gone ring. HCF, you'll see things like distribute evenly. I'm sorry, equally. You'll see things like greatest. No. Once you see greatest, maximum. How many? Like if they ask you how many can be put into each group. Right, this will be our question. If you see like split evenly, that's our next one. Split evenly and distribute equally is the same thing. So, right? So that's basically some phrases. So your homework would be indicated by what is labeled HW in red. Okay?